students, welcome to another lecture, and today we will be learning another interesting topic of electronic devices, that is MOSFET. We can say it is a type of field effect transistor infused with metal oxide which is widely used to switch and amplify the electronic signals in any kind of electronic device. A MOSFET is a core of an integrated circuit and it can be fabricated into a single chip due to its small size. Unlike any other transistor, it is a voltage controlled and unipolar device. So, it's less noisy due to unipolarity. It has 4 terminals followed by source S, gate G, drain D and body B. The body of a MOSFET is often connected with the source terminal. This type of transistor is the most common transistor that can be used in both analog and digital circuits. Let's go deep about its working principle and functioning ways. It works electronically by varying the width of a channel in which the charge carriers are flowing, that is, electrons. The carriers begin their journey from source and exit via the drain. The channel width is controlled by the voltage of an electrode which is located at the gate known as gate voltage. It is insulated from the channel near an extremely thin layer of metal oxide. A metal oxide field effect transistor or MOSFET can function in 2 ways: enhancement mode and depletion mode. Enhancement mode: when the conductivity between source and drain terminals of the device increases with an addition of applied low positive voltage through the gate terminal, then the MOSFET is said to be in enhancement mode. In this mode, the device is considered to be off. At this time, no channel will be present between source and gate and it will only conduct when the addition of positive voltage, also known as threshold voltage, is applied at the gate terminal. Depletion mode: when the conductivity of the device decreases with the addition of applied positive voltage at the gate terminal, the MOSFET is said to have a depletion mode. This mode is normally termed as on. At this time, a channel will form between source and gate. It will conduct when the applied voltage at the gate is greater than the threshold voltage. The MOSFETs are classified into 2 parts: N-channel MOSFET, P-channel MOSFET. N-channel MOSFET. In this type of MOSFET, conduction between source and drain is carried by the movement of electrons. Since the source and drain are made up of N-type material, its body and substrate are made up of P-type material. Gate can be biased by applying the positive input voltage which will attract the electrons available in the P-type substrate. The gate is composed of a layer of polysilicon which is highly doped semiconductor, often behave as metal. Silicon dioxide is a dielectric material, so it will act as a capacitor where one of its electrodes will be replaced by the semiconductor. When we apply positive voltage to the MOS structure, the charge is distributed in the semiconductor. With the addition of positive charge particles, the oxide layer will encounter a force and allow the holes to move downward. The depletion region will be accumulated by the bound negative charge particles which are connected with the acceptor atoms. The movement of electron is controlled by the positive voltage applied on the gate terminal. As we increase the positive change at the gate terminal, it starts to attract the electron, resulting in widening the channel path between source and drain terminals. P-channel MOSFET. In P-channel MOSFET, the conduction of current is carried by the movement of holes or the positive charge particles. The drain and the source are composed of P-type material, while the body and substrate are composed of N-type material. When we apply negative voltage at the gate terminal, it allows the electron in the oxide layer to move downward in the substrate layer through strong repulsive force. Hence, positive holes are accumulated around the gate region. Since the applied negative voltage at the gate terminal also attracts the holes, so the N-type substrate produces the P-type conducting channel. Now we have come to an end of this lecture. Rewatch the parts if required, and in this section we have learned Introduction to MOSFET, Operation of MOSFET, Function and Modes MOSFET, that is enhancement and depletion mode, types of MOSFET, P-type and N-type. We will be back with the other segment of this topic. Bye.